So I'm from Binghamton University. It's upstate New York. It's part of SUNY. I am the director of the Center of Advanced Microelectronics Manufacturing, which is the New York State Center of Advanced Technology. Like a Fraunhofer, they give us money, help work with companies. And the state has given us additional money to be the New York node of NextFlex. And so we do a lot of work with our colleagues at NextFlex, not only with projects with our company partners today, talk about my work with Dr. Elizadeh at GE Healthcare, but also with many, many other companies. So we have many, I just want to focus, we have many labs all under the umbrella of a larger center. CAM is one of them. We also focus on electronic packaging, heterogeneous integration, energy smart systems, advanced solar, and in addition, batteries. Professor Stan Whittingham is among my colleagues, one of the inventors of the lithium-ion battery. We also have a fantastic analytical diagnostic lab with things like X-ray microscopy, surface science, and all those things which help us to diagnose many of the issues we get into when we work with complex materials and composites such as described. I won't get into this, but we've been around since 2005. We actually started to work with the display center, which became NextFlex, which became from FlexTech, and that happened over a long period of time. And we work in a large variety of areas. Today's focus is going to be primarily on the medical devices and sensors. But our theme has generally been to deal with, and I heard this mentioned here, so I'm bringing it up, to deal with understanding the hard and soft interface. That's what it's all about when we work with these printed devices, and we have to assemble them together. In addition, we have to add the intelligence of semiconductor devices to them. So earlier today, Dr. Elizadeh presented some of the work that we've been working on for, yes, as you've been saying, about a decade in various ways. She talked about the vital sign patch. She talked about the interstitial fluid monitor system. And finish the list. Let's talk about the sweat hydration patch that we've been working on over the years. The thing I want to point out with this particular device, unlike the device from Epicor, the one that's now famous, made by Gatorade, this is a medical type device. It's capable of sensing both sodium and potassium with an all-printed electrode. In addition, it's able to measure through the dissolution of carbon resistors the volume of sweat over time. So, and it's also intended to be a light, a wearable patch. So we took all the electronics off, tethered them separately, but keeping in mind this really intended to be a medical type grade device. And we worked with many, many parties all over. A lot of demonstrations we've been able to do with the Air Force Research Lab, even the Air Force Academy, where we had all the cadets lined up with their patches after they were about to do some exercises. So let's get into this. This work was supported by the Air Force Research Lab under NextFlex, and obviously the things that I say are my opinion, maybe Dr. Elizadeh's opinion, and not that. So this work involved many, many people over the period of time. Udara helped to pull this particular paper together with help from many of his colleagues. And again, Zara is here. So there are many types of these devices. We've heard about some of them here in this conference today, even with Epicor presenting what's in the lower right-hand corner. But in the past, with others talking about various ways to measure sweat, measure types of reagents such as sodium, potassium, glucose, or other types of things, or integrated into a much more elevated, to use sweat to actually help do diagnostic medicine. Our focus was really to look at the sodium and potassium in the device itself. And over the years, we came up with 3 generations of systems. First 2 kind of looked the same. They were intended to be worn on the arm, such as the Gatorade system is used today. But we found it actually wasn't as effective as if we wore it somewhere in the back where there was a lot more sweat. So we thinned out the device. We built it in a way so it really is like a Band-Aid and can be applied to the skin, and then the electronics are attached to it with that wire. And everything's reusable in that box.